In this video, I'm planning to explain derivative of the logarithmic functions. We started with the previous subject, derivative of elementary functions, and the second one is logarithmic function. And here, natural logarithm is ln. If you remember, I have written in the previous lesson also. So ln x derivative we are starting with. The derivative of ln x is going to be equal to 1 over x. The condition is x must be greater than 0, because if x is less than 0, the function ln here is undefined. Here ln fx derivative is equal to f derivative x or fx, it should be, and fx must be greater than 0 here also. Let's see. Here for the base is ln e, and the base is e for the ln, and for the other bases like a, which is greater than 0 and not equal to 1, the logarithm ax derivative is going to be equal to 1 over x, like this one, 1 over x times ln a. And here this is again the most general one. And if you remember this formula, you can get all the formulas here also. So derivative of logarithm base a fx is equal to f derivative x over fx times ln a. If this expression is e, this is going to be ln e, f derivative x over fx it's going to be, which is logarithm e ln fx. ln fx derivative is equal to f derivative x over fx is going to be. Okay, here we have some questions, and to solve them, I'm going to write the formula here again one more time. The ln fx derivative, ln fx derivative is equal to f derivative x over fx is going to be. So here ln x squared plus 3x plus 1 derivative is going to be equal to x squared plus 3x plus 1 derivative over x squared plus 3x plus 1. 3x plus 1 is the x squared plus 3x plus 1 is the function, so f derivative x over fx it's going to be. And here one more step we may continue, which is derivative of x squared is equal to 2x, derivative of 3x is equal to 3, derivative of 1 is equal to 0, so it's going to be x squared plus 2x plus 3 over x squared plus 3x plus 1 is going to be. Okay, what about logarithm base 2? This time we have different base than e. That's why the function logarithm base a fx derivative, if you remember, is going to be equal to f derivative of over fx times ln a, which is written this time to denominator. Okay, then with respect to this one, if we solve our question, logarithm base 2 x cubed plus 2x derivative is equal to x cubed plus 2x derivative, which is f derivative x over this parenthesis sign a bit become sail like. Okay, then, and here x cubed plus 2x fx, x cubed plus 2x times ln a. The a value here it's equal to 2, so it's going to be equal to, a value is equal to 2, so this is going to be ln 2. And I have to find the derivative of this expression. Derivative of x cubed is equal to 3x squared plus plus 2 is going to be, and x cubed plus 2x times ln 2 it's going to be x cubed plus 2x times ln 2 is going to be. Okay, if we continue to solve this kind of questions, here this kind of questions, when I say these are two different functions, here also there are two different functions. This is polynomial function and logarithmic function, and I have to find the derivative of this expression, x times ln x derivative. So this is the multiplications derivative, f times g derivative I have to find, which is equal to f derivative times g plus f times g derivative. Again, I'm repeating, this is f times g form is going to be. And with respect to that one, I'm going to write the x times ln x derivative with respect to this formula, x derivative times ln x plus x times ln x derivative, and that's going to be equal to x derivative is going to be equal to 1, so it's going to be equal to only ln x plus x times ln x derivative. If you remember from the first page, it's equal to 1 over x. This x and this x, if we simplify, the answer is going to be equal to ln x plus 1. Okay, the next one here, there are two functions, again the operation between them multiplication, so e to the power of x squared plus e to the power of x squared plus 3x times logarithm base 3 and 2x minus 4 derivative is going to be equal to, firstly this is f and g, it should be, so f derivative times g, so x e to the power of x squared plus 3x derivative times g logarithm base 3, it should be logarithm base 3 2x minus 4 plus e to the power of x squared plus 3x times logarithm base 3 2x minus 4 derivative is going to be. Okay, now the derivative of e to the power of fx, let me write here, e to the power of fx derivative, it was equal to e to the power of fx times f derivative x it was. So here it's going to be equal to e to the power of fx, if x squared plus 3x, which is fx, e to the power of fx times f derivative x, which is equal to x squared plus 3x derivative times logarithm base 3 2x minus 4 plus. Now we have the second one. Here e to the power of x squared plus 3x is the common term, and derivative of the second one it should be, and if you remember the derivative of the logarithm base a fx derivative is equal to f derivative x over fx times ln a is going to be, so it's going to be equal to 2x minus 4 derivative times 2x minus 4 derivative over 2x minus 4 times a, the base here is 3, so ln 3 is going to be. Okay, here e to the power of x squared, there is a plus sign and this expression is common, so I'm going to get the common term parenthesis, which is equal to e to the power of x squared plus 3x times let me get first the derivatives, then I will get common term parenthesis, which is equal to 2x plus 3 times logarithm base 3 2x minus 4 plus e to the power of x squared plus 3x times derivative of 2x is equal to 2, derivative of minus 4 is equal to 0, so 2 over 2x minus 4 times 2x minus 4 times ln 3 is going to be. Okay, the last step only, we are going to get the common term parenthesis of these expressions, which is equal to e to the power of x squared plus 3x times, in parentheses, 2x plus 3 times logarithm base 3 2x minus 4 plus 2 over, when you get this expression, 2 over 2x minus 4 times ln 3 is going to be.